Okay, I decided to embed the webcam today. Um, Nighttime, as you can tell, 10 o'clock at night. Woo, go Miss Baca, do notes really late at night. Um, but I decided to do the webcam so that I don't know why, but I'm feeling like as if I need the webcam today. So I don't know. This particular these particular notes are about proof. And uh, proof is one of those things in geometry that when you get it, sometimes it kind of you just get it and it's like amazing. Okay. When you don't get it, it's awful. And I don't mean it like it's not something that you can just watch an example and figure out. It's logic. So it's thinking. So it's really like if this then that, if this then that. It really is that whole domino idea of noticing something and going, what can I find from this? And sometimes you just have to trust the process. Like you have to just trust where you're going, but you may not exactly see always where you're going. Okay. I personally like to work proofs backwards because I like to know where, like I work from, like when I do mazes, I start at the beginning and then I work from the end. I don't know why. It's just the way I work. Um, a proof in math is a logical path to determining a statement of validity of truth. Okay. But you can only use what you've proved before. So typically in geometry, we start with these basic uh, theorems or conjectures, which I'll explain in just a second. And and once you prove that theorem, you can use it in another theorem. But until you prove it, you can't. Now, you guys aren't really getting into the real nitty gritty of it because we just can't, and Alex doesn't. Alex kind of gives you, it baby steps you into proofs, and it gives you a lot of the same exact kind of proofs. So um, I still think it's a good exposure to them. And for some of you who are mathy, you might really enjoy this because it's very puzzly. It feels very puzzle like. It's like, here, do this and figure out this, and you have to find your path to get there. Okay, so I am going to go through a little bit of this. I do want to give you some consolation though. I am going to take the proofs and make them extra credit. So if you are able to do these topics with proof, for the proofs, okay, um, I will give you extra credit. Okay, extra credit meaning, how would I say it? Like the pie slice will be worth probably 30 points. Like every topic is worth 2 points. But if you do 20 topics, then you've got a chance for 10 extra points on your topics grade. Okay, or on your pie slice grade, rather. Not even your topics grade, on your pie slice grade, which is better. All right, so here we go. The first thing you have is proving something by finding a counterexample. Reminds me of, like I told you about that kid that's annoying in class, where you're like, you know, oh my gosh, like all you kids, and they're like, not all the kids, and you're like, oh yeah, you're right, not all the kids, right? They're totally right. This is a good example of that. You are trying to find that one exception, like, you say something like, everybody likes chocolate or something, and there's always that one person that doesn't. So you got to find that person that doesn't, and that's your counter example. Okay. So counter example, but first of all, let's talk about the word conjecture. Okay. Conjecture means it's like a statement of truth. It's like something, conjecture. It means that you are saying something. Okay. You conjecture, like you conject it, or you can't define something by using the word, but the idea is you're presenting this. Okay. Statement, conjecture. So it says, show that each statement is false by providing a counterexample. Okay, conjecture is not proven. That's probably the best way to put it. It's a statement that's not proven. Okay, if the length of AC is 32 and point B lies on AC, then AB equals 20B. What? Okay, right? Like, what's that? Okay, the only way you can understand this typically is draw a picture. Now, some of you guys are going to be better than that, but whatever. Okay, let's talk about most of us, which is you draw a segment. Wow, that's a really ugly segment. I thought it was going to clean it up and make it pretty. Okay, here it did. Okay, let's start here. If the length of AC is 32, AC, draw it. And this is 32. And B lies on AC. Okay, so let's put B there. It doesn't say it's in the middle. So I intentionally, well, I didn't do a great job, but I intentionally did not put it in the middle, you guys. Then AB equals 20 and BC equals 12. Now it's telling you what these things equal. Okay, all you do is have to find a counterexample. Well, that doesn't mean that AB is 20 and BC is 12. It could be anything. I could say that AB is 1 and BC is 31. You could say 2 and 30. You could say 16 and 16. It doesn't matter because they didn't tell you how much that. You could have many different, many different options for a counterexample. Okay. This one says if the perimeter of a rectangle, I immediately draw a rectangle anytime somebody tells me rectangle. It's just what I do. It says the perimeter. Wow, I can't do this because there we go. Let me move my tablet so it's angled correctly so I can draw. Okay. So the perimeter is 24. And it says, then the length is 6 and the width is 6. Well, look, that is 24 because 6 plus 6 plus 6 plus 6 is 24. But that doesn't mean it has to be 24. This could be 8, and that could be 8. So that would be 8 plus 8 is 16, which means this would be 2 and 2. So because 8 plus, oh, it's 24, not 20. Sorry. My bad. So what would it mean? It would be 16. That means this would be 4, and that would be 4. So it would be 8 by 4 because 8 plus 4 is 12. 12 times 2 is 24. Walk all the way around. Okay, so you just come up with a different example. Okay, you guys could come up with another example. If angle 1 and 2 are complementary, you need to know what complementary is, and that means it adds up to 90. Two angles that add up to 90. Then one of them must have a measure less than 45 degrees. Okay, does that have to happen? Look, if you have a right angle, does one of them have to be less than? Okay, here's the tricky words right here. Less than. What if I draw a 45-degree angle? What if I try to draw a 45-degree angle? Let's do this. Ready? Trying, guys, I'm trying. Okay, let's say that's 45. Well, that means this is 45. So look, these are two complementary angles, 45 and 45, and they add up to 90. Okay. Is one of them less than 45? No, they're both equal to 45. Okay. So therefore, the counterexample is 45 and 45. In that case, there's only one example, by the way. The minute we drop it down to 44 and 46, like if I draw that, we now have one angle less than 45. Okay, if the measures of angle R, angle S, and angle T sum to 180. Okay, so remember 180 is a line. A lot of you had trouble on the test with supplementary angles, and that kind of bummed me out because really it's just all about adding up to 180. So they're saying R, S, T. Okay, they add up to 180. So do you see how these all add up to 180? Woo. Then one of the angles must be obtuse. Obtuse, you need to know the definition of obtuse. That means greater than 90. Okay? Now, does that have to be true? Not at all. Look, right here, I could say that this was 88, right? And what would these have to be? It would be these, they could be something else. 88, I could make this, I don't know. If I go 180 minus 88, that leaves me with 92. I could make one of these 40 92 minus 40 is equal to 52. In other words, they have to add up to 180, but none of them can be obtuse, right? Because they said one of them must be obtuse. Well, they don't have to be obtuse. Every single one of these angles is acute. Acute is less than 90, right? All right. So that's an example right there, 52, 88, and 40. 60, 60, 60. Those are probably this would have been my go-to. 60, 60, 60. That's 180. Not a single one is obtuse. All right, so I'm going to go to the next one. You can go ahead and pause and try this one if you want to. Okay. I'll make it bigger so you can see it because I definitely can see that it's tiny. Okay, like I said, you can pause. All right, I'm going to go ahead and give a counter example. Okay, if the measures of PQ, whatever, 180, then all the angles must be acute. This is kind of like the opposite of what we just had. Well, this is not true at all, right? I could have this big old angle here. Maybe it's 170. And then I can have two little small angles here that add up to 10, like 5 and 5, or 2 and 7. It doesn't matter, like 2 and 8, whatever. The point is that all three angles add up, and all of the angles do not need to be acute. So that could be my example. 170, 5 and 5. Look, they add up to 180, but you got one obtuse angle. If angle 1 and 2 are complementary, that means complementary means they add up to 90, remember? Then one of them must have a measure greater than 45. Same thing as the last one, except this time they said greater. Okay, whatever. 45 and 45 is still the answer to that one. I hope you guys knew that. If the area of a rectangle is 36, then the length is 6 and the width is 6. So now we're saying area. Area is length times width. And now they're telling you it has to be 6 times 6 because that's 36. Well, that's not true at all. You could have 4 times 9. That's 36. You could have 2 times 18. Sorry. 2 times 18. You could have whatever two numbers you can think of that multiply together to get 36. 4 times 12. All right. Okay, letter D. If the measure of ABD equals 30 and point C, okay, stop right there. Let's draw this. ABD equals 30. That doesn't look like 30. It looks like 60. I'm actually going to try to draw it a little better. Let's draw almost a 30-degree angle. That's a little better. Okay, let's name this angle. It says ABD. The way you name an angle is you name A, the rays here, or the segments. B, the middle letter is always the vertex. Okay, always the vertex. So ABD equals 30. And point C is in the interior of ABD. So here's point C. That's an interior. See, this is the inside. Then the measure of ABC, let's do a different color so you can see this. A, B, C is equal to 18, and the measure of CBD is equal to 12, because that adds up to 30. Okay, well, that's dumb. You could have 20 and 10. I don't know what you guys picked, 15 and 15, 5 and 25, whatever two numbers add up to 30. Okay, angle addition just means they add up together. So hopefully yours are two different things that add up to 30. Now here's the proof thing. Okay, statement again. We're looking at it and we're talking about language here, like this funky language. Like, let's be picky about our language. Okay, all means all. Some means at least one. Okay, none means none. I mean, they mean what they say in math. That is absolutely true. So you just have to do truth statement. This is just whether or not you mark it as true or not. No donuts in the row have chocolate. Okay, so look here. Well, no donuts, 3 of them do. So obviously that's not true. Some donuts in the row do not have chocolates. Well, that one doesn't have one. So, yep, that's true. At least one donut in the row has chocolate. At least one. At least. At least means, at least one means one or more. If you are ever confused, put yourself in the picture and ask yourself, think, I went to the donut shop. I want at least one donut. And what does that mean? It means you want at least one. You got to get one, right? Okay, so that's true. Next one, no donuts in the row have chocolate. Well, that's not true. Some donuts in the row do not have chocolate. That's not true either. There's not a single one. At least one donut. Yep. Even though there's four, at least one. Okay. So this one, no donuts in the row have chocolate. Chick. Some donuts in the row do not have chocolate. Ah, now you might be confused. You're like, wait a minute. All of them don't have chocolate. That's not what they said. They said some donuts in the row do not have chocolates. That's true because some don't. See, they didn't say all, they said some. Okay. At least one donut in the row has chocolate. Nope, not true. Okay, so you're just evaluating truth on these. Check the next one out. If you can do the socks, you can pause it here if you want to try it. Okay, let me make it bigger. Okay, I'll give you a second to pause. Okay, and then I'm just going to continue like as if you paused and turned it back on. At least one of the sock, at least one sock rather, in the row has stripes. Nope, none have stripes. Some socks in the row do not have stripes. That's true, some of them don't. No sock in the row has stripes. Check, that's true, none have stripes. At least one sock in the row has stripes. Yep, at least one. Four have it, but at least one. Some socks in the row do not have stripes. Nope. No sock in the row has stripes. Nope. Okay. At least one sock in the row has stripes. Yep. Some socks in the row do not have stripes. Check. That one doesn't have stripes. No sock in the row has stripes. Think about this one. No sock in the row has stripes. That's false because these three have stripes. Okay, again, logic. So be careful with words. They mean a lot in geometry, especially in math. They just mean things. Okay, so now now we're getting into segment. Sorry, I need throat is dry. Segment proofs. So the way you do these proofs is think about what they gave you. So there is a thing in proofs called given. Okay, given is what they give you. So they don't just like leave you hanging. They give you some information. Okay, and that's called the given. So take a look here. I'm going to make it bigger so you can see it better. There we go. That's better. All right. So take a look. We have given AC equals DF. So here's what I recommend you do. I recommend you immediately copy the picture and then mark it up with what they give you. So for example, they said, given AC equals DF, we'll find AC. Here's A, here's C. So you want to make sure you know AC is equal to DF. Now that isn't exactly how you show it, but it's the way I'm going to show it. Typically we show it with a little line, but because there's this E and B, that makes it a little confusing. So I don't want to get confused. So these two are equal. Then I'm going to change colors so that I can mark it with colors. Then it says AB is equal to EF. So AB is right here. This is how we typically show it, not with colors. Sorry. I'm going to try to trace it just for the sake of tracing it, showing you. AB, it says is equal, means it has the exact same length as EF. The way we typically show that in geometry is we make a little hashtag mark or hash mark, little mark like that. Okay. Now they want you to prove that BC, this little piece, is equal to that little piece. Okay. This is what they want you to prove. So in a proof, the thing you are proving, okay, will be the last step. Now, what is this chart right here? What the heck is this? This is a truth chart. This is a proof chart, and it goes like this. It has, they didn't actually draw the line down. Oh my God, you guys, I'm so crooked here. I think I need to just move my tablet better. Okay, hopefully this is better. Let's see. No, not much. Okay, so typically we separate the statement and the reason. What you do is you look here at the statement, and your job is to figure out why. Why can they say this? Like, what makes it them say that that's true? Okay, and you're going to be using your properties of addition. So if you can go grab them, that would help. Those I'm talking about, and maybe you don't need to, but we're talking about additive, like property of addition, like adding, subtraction, multiplication, whatever. Those are going to be what you're going to be using here. A big one is substitution. Okay, substitution. Substitution looks like this, you guys. Okay, what I did it with formula substitution resolution, right? Formula substitution resolution. Well, if I tell you that star is equal to square plus circle, and then I say star plus triangle equals moon. Okay, well, look, star is equal to this. So I could, if it helped my argument, write my next line like this: star plus circle plus triangle equals moon. Okay, now do you see what I did? All I did was substitute in star and circle for, square and circle for star. In other words, I substituted. That's going to be really, really big in these proofs. They really like that one. Okay, so here we go. This is how you start. Typically, we start with a given. Okay, they don't always start with a given in ALEKS. They don't. Okay, so we just got to see what they did. Okay, so here's what they did. Well, first of all, let's think about this proof. You guys, do you even understand why this is true? I hope you do. Look, is DE congruent to BC? Is it? Well, think about it. This piece plus that piece equals the big piece. This piece plus that piece equals the big piece. And that piece are the same size, and so are the big pieces. So it makes sense that the little pieces are going to be the same size. Okay. I hope you see that. Okay. It does make sense if you just think about it for a minute. Okay. All right. Anyway, let's take a look at what they wrote. They wrote AC equals AB plus BC. So what did they do? What the heck did they do? They're like, oh, AC equals AB plus BC. All they're doing, you guys, is telling you the segment addition postulate. That's it. Oh, by the way, a postulate is something that you're like, duh, like anybody knows that. Duh. Like if you have this plus this, we all know it means that it equals that, like the whole thing, right? Like, like A plus B equals A plus B. Makes sense? Okay, so what they did was they said AC equals AB plus BC. That is going to be segment addition postulate. Okay, segment addition. So you would be able to see a drop-down menu and you have to pick that one. Okay, this one. Then they did the same thing for the other segment. Look, DF is equal to DE, the little guy, plus EF. Segment addition postulate. Okay. In fact, let me look. I have the answers here. Let's see if they just used that. Oh, I didn't actually put the answers to this one. That's okay. It's no problem. See if I go back. It's small again. I'll make it bigger again. Okay, that's okay. All right. So this is segment addition postulate. So you will have to plug it down. I have to write it. Addition, not additional. Okay, same thing here. Segment addition postulate. I'm sorry for this ugly writing, y'all. Okay, and then look what they did. Now you're like, why did they tell me this? Well, please check given every time you go, why did they do that? Just make sure it's not the given because look, it's the given. AC equals DF. The reason is given. They gave that to us. Those are my favorite to do. They're really easy. Just go look in the proof and you find the given ones. All right. But really the reason why they're doing this is they're kind of strategically placing this. Are you starting to see at least that they're starting to deal with the same letters? Okay, so they said AC equals DF. Then how in the heck did they get to number 4? How did they get AB plus BC equals DE plus EF? So here's what I want you to notice. Take my highlighter. Okay, what is AC equal to? It just says AC is equal to AB plus BC. Look, AC is right here, AB plus BC. Do you see what they did? All they did was substitute in AB plus BC for this. So you read this down, okay? This one went down. It isn't always down, but in this case it is down, okay? I mean, how do I say it? It's usually down. Oh my God, I can't get rid of this stupid highlighter. Come on. Okay, there we go. Okay, let me change colors. So, down. Okay, I don't know why it's looking like that. Why am I in line? I hit some line tool, y'all. That's hilarious. Okay, let me not do that. Can I escape? Let's see. Escape this tool. Did I hit line? I did. I hit line. I don't want to do that. Okay, there we go. I was like, what the heck? Oh, look, you guys have a line tool. I forgot about that. Okay, cool. Where's my mouse? My mouse disappeared, y'all. Okay, there it is. All right, so you get it? What they did was they substituted in this for the AC, and they did the same thing over here. DF is equal to DE plus EF, and there it is. See, this equal sign is that equal sign. All they did was substitute, so that's the answer. Substitution. And then look what happened now. Why did they just all of a sudden change their method? And they're like, AB equals EF. I tell you, when they do that, look at the given. There it is. Given. Okay, we already know that AB is equal to EF. They gave it to us. Okay, now what did they do? Okay, take a look. They said AB equals EF. Look, here's the AB. Doesn't this equation look like that equation? Except what's different? EF is the same. Not okay. Okay. EF is the same, DE is the same, equals BC. What's different? The AB turned into an EF. Why? Because AB is equal to EF. So we substituted it in. Substitution. And then how in the heck did we just end up with BC equals DE? Check this out. If I subtract EF from both sides, it cancels out and I'm left with that. So the last one is subtraction, property of equality. That's how it should show up. Subtraction, property of equality. All right, whew, that's a lot. I know it's a lot. It's okay. I know it's a lot. Just bear with me. It'll start making sense as you start doing more. The first time you do this, you're going to be like in the dark. It's just going to feel crazy. Luckily, they give you a lot of the same ones, okay? Take a look at this one. This is another one, okay? And it's segment. So let's see. Okay, so let's see. It's just given us one segment. Let's take a look at what they got and let's see if we can reason through this. You guys are welcome to try to do this, like pause it. Otherwise, I'm going to do it, okay? And I'm not going to just check it. I'm going to actually work through it. So look, it says given AC equals BD. AC equals BD. prove that AB equals CD. They want us to prove this. AB equals CD. Okay? Does that even make sense? Think about that for a minute. If these two pieces add up to these two pieces, and we know that if these two pieces add up to each other, okay, and we know that they share the same piece. They both share BC. Doesn't it make sense that the little pieces are going to be the same? That's kind of what you do with the proof. You kind of like look at it and you kind of think through it. Okay, you think like, do I believe this? Why would I believe this? Okay. And this is where you just have to start to try to think things through. All right, so let's see what they did. First thing, you can always look to find the given, by the way. Look, see, given is AC equals BD right there. Boom, given. That's what I do. It's the easiest one. I do remember doing proofs in high school, and I would look for the givens, and I'm like, 2 points already. All right. AC equals AB plus BC. Okay. AC equals AC. I think I can erase. Hang on. Yes, I can. I actually tied everything down today. Okay. So again, it says AC is equal to AB plus BC. That's segment, addition, postulate. Duh. That's what I always think when I say postulate. Okay, this one, BC plus CD equals BD. Okay, again, I'm just going to put that there. Segment, addition, postulate. You're not allowed to do that in a proof. I'm just doing it now in notes. Okay, then you got this given. Now, why again did they do that? Because look, with the given, look at what AC is. So look what they did. They substituted in AB plus BC for AC. Then they did it again with the second one. So BC plus CD is equal to BD. So look, they substituted it in there. Okay, right here. Okay, because that's BD. All right, and then they jumped to the end. Well, what did they get rid of? That's what you need to pay attention to. What did they get rid of? And they got rid of the BC. That's because they subtracted BC from both sides. And they got rid of it. Okay, and this one is subtraction property. And this one is substitution. Okay. All right, next. Let's see if some of this is starting to stick. Oh, no. Come on. Whatever. Okay. Oh my gosh, come on. Okay, there we go. Right, so here's one. And it feels a lot, to me, it feels like the exact same thing, but now we're given angles. Woo! Okay, so do I have the answers to this one? I do. Okay. Why? Right. PWQ? I do. Okay. Okay, so here's what it says. It says, use the given information to prove that measure of angle 2 is equal to the measure of angle 4. Okay, here, let's look at our givens and let's mark them. It says measure PWR. So we go PW, that's the big angle. I'm going to mark it in blue. PWR is equal to SZU. Boom. These two big angles are equal. Okay. Then it says the measure of angle 1 equals the measure of angle 3. So the measure of angle 1 equals the measure of angle 3. Now, doesn't it just make sense that the angle 2 is equal to angle 4? And it seems kind of stupid to prove it. You're like, duh, it's so easy. But that's what proofs are. It's sort of like using logic to get there. So you can, sorry, my daughter is calling and I I don't know if you can hear that. I just need to be like, no. Okay. Great. Okay. So what we're going to do is measure of angle 1 equals measure of angle 3. Okay, so now we need to get here. So we are going to start. Now, all you have to do, remember, is to fill it in. But here's the thinking, right? You can do angle 1 plus angle 2 is equal to angle PWR. Do you see that? PWR. Okay. Why? Say angle addition postulate. Okay, the two angles add together, two small angles add up together to get the big angle. I wonder if I can move my face. I can move my face around. This is so cool. Okay, so then you could do it the other side. You can go angle 3 plus angle 4 equals angle SZU. Correct? Everybody agree with that? Again, so both of these are going to be, I keep saying segment. That's not right. Angle addition postulate. 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 Okay, both of these are those. Then what are you going to do? Okay, then you're going to state the given. Because look, we're going to be able to do the same thing we did last time. PWR is equal to, and I need the M, the measure of, I guess I need M's on all of these, you guys. Don't be lazy, Miss Baca. Can't do that. That's bad form. Don't do that. The measure of angle SZU. And that answer is given. Why? It's given. Now we're going to go, what is the measure of PWR? Well, here it is right here. It was defined right there. So we're going to go measure of angle 1 plus the measure of angle 2 equals, what's SCU? SCU is measure of angle 3 plus the measure of angle 4. Okay, now we're still not lost here. Why? Because we still have another given to use. Look, it's right here. It says the measure of angle 1 equals, I'm going to grab this and move it a little bit up. Okay, the measure of angle 1 equals the measure of angle 3. Given. Oh, this one was substitution. We substituted in, yes? Okay, so now this is given. Okay, what can we do with this? We can either substitute in a measure of angle 3 here, or we could substitute a measure of angle 1 here. It really doesn't matter. I'm going to go ahead and substitute in for here. Measure of angle 1 equals the measure of angle 3. Why? Because I can see that I'm going to be able to eliminate it and get to my proof, which is 2 and 4. So I'm going to go the measure of angle 3 plus the measure of angle 2 equals measure of angle 3 plus the measure of angle 4. Why? Substitution. Okay. And then subtraction will get you to the measure of angle 2 equals the measure of angle 4, because we just subtract the measure of angle 3 from both sides. Subtraction. Okay. I hope you're starting to get it just a little bit. These ones are super beginner, so it's mostly about just recognizing these properties. So here's the actual answers. They did a given first. I did the given third. Then they did the angle addition property. Then they substituted it in. Then they stated their other given. Then they substituted it in. And then they have addition and subtraction properties. It's subtraction. I don't know why they put addition and subtraction. I guess maybe they group them together for this. Okay. Just gives you an idea of what the actual answers were in ALEKS. Okay, so I guess they do group them together. Typically, you have to state which one it is, addition or subtraction. All right. Which brings me to another point. I didn't put this in the exact same order as them. It's still fine. Okay, it doesn't matter. It's still the same. Okay, I still proved it. Sometimes there's like many different ways to prove something. Okay, take a look at this. Kitty. Oh my God, you guys are you're getting my kitty chin. Did you guys see that? That was my cat. He's right behind he hangs out with me all day, I swear. But he's right behind the computer. He bent over to look in the camera. That was funny. Okay, here we go. Is this the last one? I think this is the last one. Okay, if you want, stop the date. Try to do this one. Okay, here we go. Let's do this. Let's mark it up. It says given measure of ABC equals the measure of EDC. ABC, C, EDC. So in other words, this big one is equal to this big one. Oh my God, are any of you guys cat people? My kitty is chewing on literally everything. I wonder if he's teething. He's like 6 months. Chewing on everything, including me. All right. Then it says the measure of angle 1. I'm going to switch colors. Let's do green. I haven't done green in a while. Measure of angle 1 equals the measure of angle 3. Oh my God. I'm going to make it through before my cat pulls. Okay, measure of angle 1 equals the measure of angle 3. So here's 1, and it's equal to the measure of angle 3. So what are they going to ask you to prove? That 2 is equal to 4. Duh. It's the same thing we've been doing. Okay, so first what you do is state the given. Okay, you can state the given. This time I'll do it their way. Measure of ABC equal to measure of EDC given. 1, 2. Then we're going to go ahead and state what the measure of ABC is. What is the measure of ABC? What is it? ABC means it's the measure of angle 1 plus the measure of angle 2. And that's angle addition postulate. Because we're adding them together. Okay? Then number 3 is define the other one, measure of EDC. Measure of angle EDC equals measure of angle 3 plus the measure of angle 4. Same reason. Okay, next. Then we're going to go 4. Okay, now we're going to substitute. Same thing. This is going to go in for that because that's what it is, see? And then this is going to go in for this, right? Because that's what it is. All right, so we're going to just replace. We're going to take this equation and we're going to replace it. ABC is measure of angle 1 plus measure of angle 2. EDC is measure of angle 3 plus the measure of angle 4. Substitution. Then 5. Okay, now we're looking for another given. We can't really do anything with this, so we need something else. So you go back up and you're like, oh, look, they gave us that. Measure of angle 1 equals the measure of angle 3. Okay, so this is exactly like the last one. And all we have to do, this time, I think I'll plug in for measure of angle 3. Measure of angle 3 equals measure of angle 1. So measure of angle 1 plus the measure of angle 2 equals the measure of angle 1, because that's what angle 3 is equal to. Measure of angle 4, by the way, this one was given. This is substitution. And then 7 is the answer, which is the measure, because these cancel out. Measure of angle 2 equals the measure of angle 4. And now we have proven it with subtraction. All right? And that's the idea of proofs. All right? Step, 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 step. Domino, 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 domino. Okay. And here's the answer. Okay. Basically, exactly what I did. Yep, pretty much exact. So for some reason, why did they put 4 plus 3? Whatever, you weirdos. Just have to go against the grain. But it doesn't matter. Same. Okay, I'm pretty sure that's it. Yep, that's it. Good luck. Good luck.